So example 4 has a bunch of transformations. We've done questions where things were just moved left and right. We've done things in the last section where there was different horizontal and vertical stretches and compressions to figure it out. But we've never done one where there could be stretches, compressions, and translations. So what we're going to do, and don't write this first part down, but we've gotten used to, we take a point, we do one set of transformations, take a point, and do another set of transformations. And we always did our stretches first, and then our translations. And that's the idea that's going to help us figure out how to do this question with the two graphs. If we're starting with our red graph and we want to get to our blue graph, we would have done all of our stretches and compressions first, and then we would have done our translations. So if you want to write down sort of our steps for this one, first of all, number one, we're going to look at the vertical and horizontal distances to figure out, and I'll just write stretches, but it's stretches or compressions. Just like we did in the last section where we looked at our vertical distances and our horizontal distances to figure out what x was multiplied by and what y was multiplied by, we're going to do the same thing. Now, in our last example, that's all we needed to do and we were done. But now, there's also going to be horizontal and vertical translations. So after we've done step 1, step 2 is we're going to apply these stretches to the graph and plot those points. And you'll see what that is when we go through this example. So we're going to figure out what our stretches are horizontally and vertically. Then we're going to plot those points after that stretch. In other words, we're going to be plotting this point right there, the middle point. Oops. Step 3. Step 3, we can use our points to figure out the translations. And finally, step 4, we can write the equation. Going to make them smaller so you can still read them. Okay. So first step, we are going to figure out our vertical distances and horizontal distances to find our stretches. So if we look at our vertical distances, A to B and, well, I'll do that in red, that's on our red graph. A to B, and on our blue graph, from A prime to B prime. Now I want you to look at the graph, and I'm going to be very fussy. What is the distance from A to B? 16 down. So to be really fussy, we're going to write negative 16. So the distance is 16, but because it's going down, we're going to write negative 16. Okay? How about from A prime to B prime? Goes down 8. So in this case, what's happened to y? Y has been divided by 2 or multiplied by 1/2. So in this case, had you not been really fussy and just did 16 and 8, you would have got the right answer. But there's going to be some examples in your homework where one goes down, the other one goes up, and there's actually been a reflection. And so you have to be fussy so that you get that reflection as well. So in our vertical distances, our y is getting multiplied by 1/2. In our horizontal, distances, when we look at A to B and then A prime to B prime, A to B is positive 2. A prime to B prime, also positive 2. So nothing's changed here. X has been multiplied by 1. So there is going to be no horizontal stretch or compression. So that was step 1, figuring out what our stretches and compressions were. If we read step 2 again here, step 2, apply those stretches to our graph and plot those points. So our original graph was the red one. If I multiply the x by 1/2 and the y by 1, point A will go to 0,4. Point B, if I multiply the x by 1 and the y by 1/2, point B will go to 2, -4. So step 2 is just applying those stretches, compressions to our points and showing where they are on our graph. Once you've done that, how would I have to move those green points to match up with the points on our blue graph? What would I have to do? 4 down and 2 to the left. 2 to the left, 4 down. So once we plot those points, it's going to be easy for us to see what the translation is. And we have to go 4 down because we notice that it goes by 2s. So we go down 4, 2 to the left, and it matches up. Down 4, 2 to the left, and it matches up. Now that we've got what y and x have been multiplied by, how it's moving left and right, we can now write our equation. Start with, it's an f of x, so it's going to be y equals y by 1/2, that 1/2 would show up in front. F of, we don't need to show x by 1 because that won't change anything. The only thing happening to the x is it's moved 2 to the left. How do we show that? X plus 2 inside the function, and finally down 4 afterwards. There's our equation. Questions you can do for this one. Question number 9. And we'll work on that, and that's where we'll end today.